Welcome to Module 3, Lesson 4. Let's talk about one of the unsung heroes of Layer 2 networking. In this lesson, we're tackling Spanning Tree Protocol, or STP, the mechanism that quietly keeps your switched network from tearing itself apart. We'll look at why redundant links, the very thing that's supposed to make networks resilient, can also bring them down, and how STP steps in as the elegant fix. So here's the core problem. Picture 4 switches wired in a square for redundancy, SW1 to SW2, down to SW4, across to SW3, and back up. The moment a single broadcast frame enters that ring, it circles endlessly, because unlike IP, Layer 2 has no TTL to kill it off. Within seconds, you get a broadcast storm, MAC tables flapping as the same address appears on multiple ports, and hosts receiving duplicate frames. The network doesn't just slow down, it collapses. That's where Spanning Tree Protocol steps in, IEE 802.1d, the elegant fix for that collapse. It works in 4 steps. First, the switches elect a root bridge, a single reference point for the whole topology. Then every other switch calculates its lowest cost path back to that route. Any remaining links, the redundant ones, get placed into a blocking state so traffic only flows along the chosen tree. And if an active link fails, STP wakes up one of those blocked links to heal the path. One active route, backups parked and ready. So how do the switches actually pick that root bridge? They send each other little messages called BPDUs, and inside each one is a bridge ID, a combination of a priority value and the switch's MAC address. Lowest bridge ID wins, priority defaults to 32,768 and moves in steps of 4,096. So the lower you set it, the better your odds. And here's the practical tip. Set your core switch as root explicitly. Don't leave it up to whichever switch happens to have the oldest MAC address. Once the root is elected, every port walks through a sequence of states before it can safely pass traffic. It starts in blocking, where it only listens to BPDUs to make sure no loop is forming. Then it spends about 15 seconds listening, another 15 learning MAC addresses, and finally lands in forwarding, fully active. Disabled just means someone shut it down manually. Add it all up, and classic STP takes 30 to 50 seconds to converge, which is exactly why RSTP was invented. And that 30 to 50 second wait is exactly where we pick up next time. In Lesson 5, we'll dig into Rapid STP, the modern flavor that converges in just a few seconds, plus Port Fast, which lets access ports skip the waiting game entirely. If this lesson helped the pieces click, hit subscribe and turn on notifications so you don't miss it. The full CC course is free on YouTube and over at Dargslan.com. See you in the next one.